Hello, ladies and gentlemen. Welcome back to Math 30-1, Chapter 3, Section 5, Inverse Functions. Now, are the following inverses? I don't know. Y equals 3x minus 2, y equals x plus 2 over 3. Let's find out. X equals 3y minus 2. X plus 2 equals 3y. Divide by 3, divide by 3 equals x plus 2 over 3. Yes. Now, what about the other equation? Probably not at my luck, but let's find out. X equals y squared minus 2. So x plus 2 equals y squared, or y equals plus or minus the square root of x plus 2. No. This is a minus only. It's x minus 2, so no. Double no. All right? Now, here's the other thing I need to talk about. I want you to recall the vertical line test. If you can draw a vertical line through a graph and it touches the function 2 or more times, the graph is not a function. Actually, it touches the graph. Okay. Poor wording. So we look here. 3x, y equals 3x squared minus 2. We reflect that. Oh, you poopy heads, so that people are watching. Reflect that across y equals x. This is going to be you notice here that this is not a function because it fails the vertical line test. So the inverse is not a function. So my question is, what can you do to restrict this graph, this original? So the inverse is also a function. Well, what we talk about here is make it pass the horizontal line test. Draw a horizontal line. If it touches the graph more than once, the inverse is not a function. So what do we do to this original function? Well, cut it up. Here, x is greater than or equal to 0. What happens here? Well, I don't have to calculate this. I can just look at the inverse and I go, okay, it's going to go like this. And yes, this passes the vertical line test. This is a function. Passes the vertical line test. And notice the original function passes the horizontal line test. Doesn't matter where you draw this line. It only touches the graph once. Doesn't matter where. Okay. So if the original function passes the horizontal line test, the inverse passes the vertical line test and is a function. So, another place I can cut it is right here. X is less than or equal to 0. My reciprocal function will look like this. And it will go like that. And this is a function. Because this original function passes the horizontal line test. Doesn't matter where I draw that line, I only touch the graph going across once. So the inverse is also a function. Okay? Oh, and yes, this is the line y equals x. Okay? Now, I want you to note here, I'm cutting it at the vertex, the bottom part. That's easy, usually easy to find and easy to define if I give you the equation or the graph. Now, what about inverse functions you cannot easily graph, like this one, y equals the absolute value of x plus 1. Here, you would reflect this across y equals x. So your inverse function is down here somewhere. And I'm going, this is x equals the inverse value of y plus 1. And I can't put that in my graph and calculate. Well, I might be able to, but I'm not going to try because it's not worth the aggravation. All right? So, that's right. So where would I cut this original function off so that the inverse is also a function? Right here at minus 1 comma 0. So I would say for this, x is greater than or equal to minus 1, or x is less than or equal to minus 1. Okay, now that's the best spot, right? Are there other spots I could choose? Yes. I could choose almost any other spot if I'm careful. For example, I could choose here, minus 2 comma 1, as long as x is less than or equal to minus 2. If I'm less than or equal to minus 2, I'm here. Sorry. My bad. As long as I stay less than minus 2, I pass the vertical line test. Because remember, this part of the graph doesn't exist. So yes, I pass the vertical line test here. Now that's being really sneaky. Okay? But I want you to remember, as long as you can pass the horizontal line test. Now, if I put the point, now what happens if I go to the other side? X is greater than or equal to minus 2. Well, the problem is, I go down here and, I fail the vertical line test. So I have to be careful which point I choose. Usually one side or the other of the vertex or the peak is best. But, as I said, how picky and evil are they going to be on the diploma? I don't know. But here's a typical diploma question. What is a restriction on y equals absolute value of x plus 2 minus 3 so the inverse is also a function? Now think about this for a sec. Now, I'm not going to draw this graph. Well, actually, let me phrase that. Yes, you should draw the graph. It doesn't matter. Draw the graph. So this becomes x minus 2. So this is something like minus 2 minus 3. Something like this. So there's a vertex down here at minus 2 minus 3. Okay, so where would I cut it off? Less than or equal to minus 2 works. Or greater than or equal to minus 2 works. But that's the best spot. Now, note here, if I cut it off at x equals 2, I'm over here, and I will definitely fail the vertical line test. If I cut it off greater than minus 3, minus 3 is over here. And once again, I will fail the vertical line test down here. Sorry, the horizontal line test down here. And x is less than 3. Yep. I'm going to fail the horizontal line test again. So the inverse will fail the vertical line test and it's not a function. All right, I'm going to be quiet now because I need you to look at this and think about it. If you got it, work on the homework questions. If not, shoot me an email or see me in class. Good luck.